Good morning, everyone, and good afternoon, everyone. We are recording our session on June 14th. Today is Wednesday, and we're going to work on Chapter 5, Section 4. If you go look at the student assignments, statistics, all assignments, you're going to see 4.5 problems, 5.4 problems are there. Hopefully, after the lecture, you will be able to handle them. Again, if you cannot handle them, email me. I will be happy to help you. Send me a screenshot and name your class. Another thing, your exam will appear here. And before the exam, I will tell you. So make sure you're keeping up with the class and make sure you do all your homework. I want to make sure your exam environment is similar to your homework environment. Hopefully that'll help you do better. Thank you. So let's start our section 5.4. So this is about conditional probability. Okay. So this is a clip from your book. The notation probability of P given E, this vertical line, we read it given that, something like that, given. Okay. The probability of event F given event E. So you need to find the probability of F if E has taken place, or you know another condition. So the part that follows the vertical line E is called the condition. Okay. Generally, it follows after the word given that. Okay. Given the event E. It's the probability of F occurring given event E has occurred. So I'm going to give you a very simple example because it is a difficult concept, okay? It is a difficult concept. So suppose you're rolling one six-sided die, okay? Only one, not two. And your sample space is going to be this. Sample space is going to be this. Now, what's the probability of getting a six? Clearly 1/6, right? But now, if I say that what is the probability of getting a six? Let's write it down nicely. So my E, F is going to be the probability of getting a six. Okay? F is getting a six. And E, and you really want to get it. It's not a difficult concept, but students find it difficult, given that you got an even number. You got even number. Okay. Now read it like this. I want you to find this. I want you to find this probability. Probability of F, probability of getting a 6, given that you got an even number. That changes everything. Okay. Now let me see if I can do a slightly better job. I don't think I can because it's giving me an absolute value sign. I want just this line. All right. So this line is a vertical line and you have to get it. Okay. This is just a vertical line. All right. Okay, so how do we read it? Find the probability of F given E that's taken place. What is F getting a 6? What is E? You got an even number. So what happens? If I tell you I roll a die and I got an even number, what's the probability it's 6? You're going to say this. You're going to say that's easy. There are three even numbers and it's 6 is one of them, 1/3. That changes everything. excuse me, it's not one sixth anymore, it's one third. Okay. So once again, this is called conditional probability. Conditional probability generally adds a condition to the sample space and makes the sample space smaller. Right now, my original sample space had 6 items, but the moment I add the condition, you got an even number, the sample space shrinks to this. When I say you got an even number, I'm only talking about these. So my sample space shrunk. And my new probability of F given E, or you can say probability of getting a 6, given that you've already obtained an even number, or you already got an even number, you're gonna do it like this, one third. So we're gonna do a lot more. I gave you a very basic example on purpose so that you can understand the concept. Okay. Now, this example, I'm just going to share with you. It came from your book, but I discussed it. I'm not going to go over it again. It's right here. You can read it. Okay. So let's try a problem. This is also from your book. I'm going to make up some of the questions. So, so what this is table 8, and your book has a bunch of problems on table 8. I'm going to make up the problems, but I do want you to understand what the table is about and what kind of questions I can give you on the exam. So basically, I have males, females, 2 columns, and the third column has the totals. Sure, and they're correct. I'm not going to check it. And the males are never married, married, widowed, divorced, separated. Total, total. And the females, same thing. And you have a bunch of totals here, and you have a bunch of totals here. This is the entire population. Okay, 260.1 million. That's just a table. Now, what kind of questions I can ask you? Okay. So I'm going to try to write it down. Okay. You can do the ones from your book. They're going to be very similar, but let me write it down. If I say I want you to find this, what's the probability? The probability that you pick a person here, and the person is a male, is a male. Given that, I'll bring it to the right place. Okay. Just be a little patient. Given that, given that he is widowed. Widowed. Now, he is widowed. So when I say, given that he is widowed, this is the condition. This is the condition. Maybe not a good idea. It makes it too small. The condition is going to be this. The moment I add that condition, you're not looking at the whole population. You're only looking at the widowed people. So, widowed, you're only looking at this little group. All right. This is important to know. Given that, excuse me, given that, the moment I say given that, that's the symbol that was after the vertical line, okay? So you're only talking about this. So now, what's the probability that the person is a male? So you're going to take 3.3 and divide it by 15.2. Answer is going to be 3.3 divided by 15.2. So which turns out to be, let's find out, which turns out to be about 2.17. Now, I'm going to make a couple of points here, guys. So, conditional probability, you don't look at the entire population, which is 260.1 million. You're only looking at 15.2 million people. The moment I say, given that the person is widowed, you're only looking at that tiny population. Okay? So the answer is 0.217105263. Now, I'm repeating myself. The problems I'm using are just made up, but if you go to your table 8, there are some more problems done in the book. Feel free to take a look. Okay, so it gives you more examples. So let's say I change it to find the probability that the individual, the person is married, given that the given that the person is a female, the person is a female. Okay, how do we do that? Very, very similar. Okay, so I'm gonna highlight this part. The person is a female. We're only talking about females. Okay, if we're only talking about females, I don't care about the whole table. My focus is this. My focus is going to be the middle column. Excuse me. All right. Now, I want to know if I'm only looking at the females, I want to know what fraction of the females are married. Well, there are, uh, this is the number of married, total number of females, and married is going to be 62. And I'm going to go use my calculator to find the answer to that question. I'm getting 45.45. That's your answer. Okay. So when a table is given, you want to read the part that's after the person is female or the person is divorced, all those things. And then you just focus on that and you find the probability, whatever probability they're talking about right here. Okay. Let's see what else is coming up. All right. This is important, guys. Okay. This is important and this is going to confuse a few of you. I hope it won't be too bad. So, so far we had an intuitive feel for probability of F given E, which is conditional probability. It can also be written as, defined as probability of E and F divided by probability of E, which is same as, uh, because the denominators cancel here, there is a denominator, the number of ways E and F can take place divided by E. If you don't like this, don't worry about this second part too much. But if we run into a problem, I'll address it. Don't worry. The probability of event F occurring, given the occurrence of E, is found by dividing the conditional probability of E and F happening at the same time divided by probability of E. Now, it won't make a whole lot of sense right now, but it's something we're going to use. And when we use it, it'll make a little more sense. Little more sense. Now, one thing I would mention at this point, this formula, you can multiply this and and write another expression that will show you what P of E and F is. So I'll tell you what I mean. So all they did here, they multiplied, they're calling it generalized multiplication rule. What is that? Well, that's not anything too deep. What they did is they're saying this guy, P of E and F, is simply P. probability of F given E times probability of E. That's all they're writing. Okay, so basically it's called generalized multiplication rule. It's really like the multiplication rule, but you make a little adjustment. Okay, when two events are independent, just like you multiply, it's very similar, except for when E has taken place, you find the probability next time. Again, when we're going to do the math problems from your book or from MATLAB, you're gonna understand it a tad bit better. Okay, so let's try a problem from your book. The probability that a driver who is speeding gets pulled over is 0.8. So the probability that a driver gets a ticket, given that he is pulled over. Now let's write it down nicely. Let's write it down very nicely. Okay, writing down a few things nicely will save you a lot of time. So I'm going to say, um, given that she is pulled over, probability given that she is pulled over. Okay, let's say pulled over, pulled over is E. Doesn't matter what you call it, okay? The event of being pulled over is E. Okay, just because you're pulled over doesn't mean you're going to get it. The probability that a driver is speeding gets pulled over is 0.8. And the probability that a driver gets a ticket, given that he is pulled over. So I'm thinking a little bit about how I can write it the best, okay? So give me 2 seconds. And the probability the driver gets a ticket is F. I'm going to call it F. Gets a ticket. Okay. Now, this is given as 0.9. So they are saying the probability that a driver gets a ticket, the driver gets a ticket, given that he is pulled over. Now I can write it like this. And that's important, guys. That's very important to write this. I'm working on the second line. So basically, I'm finding out this F given. Again, this is, I can't, they won't let me change it, but this is not phi. This vertical line is given that, okay? So make sure you understand this is not FIE. This is equal to 0.9. This is given. They're telling you this probability. Once you define E and F, they're telling you the probability that you're going to get a ticket, given that you're pulled over, is zero point 0.9, which is very high, which kind of makes sense. What is the probability that a randomly selected driver who's speeding gets pulled over and he gets a ticket? So remember our little formula involving conditional probability. That's going to come in handy. Uh, Probability of F given E is probability of F and E divided by probability of E. Okay? So I can say this. This is from my previous slide, right? Now I do know 0.9, and what's E? Pulled over, the probability of being pulled over, okay? It's zero point 0.8, all right? So I know this, and I need to find this. So I can write this like this. I know two of the items. I know probability of F given E is 0.9, and probability of E being pulled over, given you're speeding, is 0.8. And I can just cross multiply and find probability of F given. Let me move these around a little bit. So what I'm going to do, I need to know the probability of randomly selected driver who is speeding gets pulled over and gets a ticket. I'm just going to multiply zero point 0.9 by zero point 0.8. So let me write it down nicely. Cross multiplication. There we go. That's your answer. Okay. 0.72. Using conditional probability and reading it between the line and making sure you know what's given, you know what they're looking for. Again, the word and is going to show up over and over again because in the main formula, and is right here, and this is called given that. All right. Hopefully that helps. By the way, the problem that I just did was done in your book. Take a look. Okay, this is very interesting. This is an interesting problem. We're going to do it very patiently, and it's a hard problem. I've assigned a couple of problems like this in your math lab. So let's read it carefully. Suppose that of 100 circuits sent to a manufacturing plant, 5 are defective. It's known that out of 100 circuits, whatever they are, 5 are defective, 5 are problematic. The plant manager receiving the circuits randomly selects 2 and tests them. She's not going to test 100 of them. 100 circuits, it's too time consuming. If both circuits work, she will accept the shipment. Otherwise, the shipment is rejected. What is the probability that the plant manager discovers at least one defective circuit and rejects the shipment? So let's write it down. What is the probability that the plant manager discovers one, at least one? Remember, guys, when we talk about at least, we want to be a little extra alert when we talk about at least. So let's first find out both the circuits, the probability that both circuits will work out. Let's find out that. Find the probability that none are defective. Let's write it down carefully. Probability that none are defective. However you want to say it, you can say both are fine. Let's just write both are fine. Probability that both are good. Probability that both are good. Now we're going to use generalized multiplication rule. Don't let that bother you. It's a fairly easy concept. So you want to find, you're going to draw one. What's the probability of getting a good circuit? 5 are bad, 95 are good. I'm going to say it's going to be 95 over 100. Now, remember the generalized probability is is based on the condition that you got a good one first. Okay, so now I'm going to multiply it by the second probability of getting a second good one. Now, you have to be a little careful here, guys. You don't have 100 circuits anymore. You pulled one out. Okay, that's how it's done. They're not going to put it back. Pull one out and there are only 99 circuits left. How many good, let's say you got the good one first. So you got a good one. So there are 94 good ones in the packet and out of 99. And that should be your answer for this, but we're not done. Now, what I'm going to do, I'm going to just find the decimal answer using my calculator here, okay? Just to keep things simple. So I'm going to go here. I'm going to say 95 times 94 divided by 100 times 99 would do it at 0.90. 0.90. So that's the probability that both circuits are good. But that's not what I want really. The question says, what's the probability that the plant manager discovers at least one defective circuit and rejects the shipment? So they really want us to find the probability of getting one defective one. Probability of getting one defective one. Just let's just write one defective. Probability of getting one, at least one defective, and it's important to write the word at least one defective, and that's easy. I just have to subtract one minus 0.9020, all the other numbers, but that's good enough for me. Okay, so it's going to be a small number. I'm going to do it here. Very small number, 0.97. I think if they ever ask you if something is unusual, if it's less than 5% or 0.05, you will say it's unusual. So it's not unusual yet. So there are a couple of questions like that. Okay. So this is the answer. This is the answer I'm getting. I'm going to check the answer in the book. Yeah, same. They got 0.098 and I got same thing, 978, 979. So that's that. And what I'm gonna do, guys, I am gonna do another problem from your MATLAB assignment. That'll be a little difficult, and I'll try to do it on the next video. So there will be a part two. So